So this property is interesting in that it's a property that I surveyed in the past. There is brown at the base of the wall. Now, you get brown discoloration when water passes through building material or it comes into contact with metal and also timber releases a lot of brown staining. Now, I surveyed the property before it was purchased and there was no staining on this internal wall and it was dry. External walls were damp. So during the survey, so this obviously current survey, I checked in the subfloor void and there were no issues with dampness there. There's a clear sign of a damp-proof course, not that they're particularly necessary, but it illustrates why you're getting heat loss at the base of the wall because you've got cold air going in underneath the floor all the way across. I looked in the neighbouring property and there is a bathroom on the other side of this wall. There were no gaps or cracks in the grout. There were no obvious signs of dampness along this wall. But what I did find out is it was recently purchased and the predecessors almost certainly were away for large parts of the winter. And that would result in low temperatures on the other side of the wall. And I think this was what was exacerbating the problem. The other thing I heard is the previous occupant had bookshelves up against the wall. Now, bookshelves are great and better on internal walls than external walls, but the problem is that they stop the airflow, the heat from the radiators. This time of year, you can't tell so much with the thermal imaging camera. But if there were 10 degrees centigrade difference between the inside and outside, particularly if the outside was, the neighbouring was unheated and the bookshelves were there, what we would see is a lot of areas where there was low temperature relative to the inside. And that's because the airflow from radiators won't get in past the bookshelves, particularly if there are lots of books. Now, I measured the relative humidity in the subfloor and I found that the dew point was pretty much identical to the internal dew point, which tells me that there was no more vapour in the subfloor than vapour in the property itself. Very interesting, and it's something that should be checked on surveys, and I try, or I do, wherever I can lift the floorboards up. Clearly, you need permission to lift floorboards because I'm removing a bit of the carpet in order to do that. But what you notice is, so there's heat loss in the floorboards, which is creating condensation along the top of the skirting board, and it's the water coming into contact with the skirting board that's causing the brown colour. There's also mould growing along the base of the wall. Now, you don't get mould if you have rising damp. I think the suspicion was that there might have been rising damp, but there was no rising damp. It's in London where the groundwater's pumped out. And anyway, there's a low risk of rising damp in the area. And if there was rising damp, which there wasn't, you would have high humidity in the subfloor void. One of the biggest concerns of rising damp is it causes condensation in the subfloor void above the damp-proof course. If you look at this survey, you'll see more examples, and I'll link it again at the end. So yeah, this is using a hygrometer probe in the subfloor void, and it's worth anyone. They're very inexpensive. You need to. It's normally best to buy quite a few at a time and just calibrate them against salt. Now, so we're going to go and have a look at the data loggers in a sec, but what's important to know is the dew point. The dew point, which you can just see as 12.3, is the temperature where condensation takes place at. It's also a measure of the amount of vapour in air expressed as degrees centigrade. The benefit of this is that you can compare it to the internal and external temperature. What you want to do is keep the internal dew point below the outside temperature, and that's just as important when the property is vacant as when it's been occupied. And one of the big problems is that people turn the heating off when they leave a property unoccupied, and a lot of the property will go down to a temperature similar to the outside, especially above a well-ventilated subfloor void. You're going to get lots of low temperature close to the base of the wall, which is why you're getting condensation there. Simplest solution and cheapest and most environmentally effective is to use a 20-litre dehumidifier. 20 litres is the sweet spot, in my opinion. And if it's regularly around or above 12 degrees centigrade, it's better to use the compression type, or desiccant if you're going to let it get very cold. The other thing is that the bathroom extractor fan was switched off, which, because the bathroom's just next to the bedroom, I think it's the noise which is the reason why it's switched off, and therefore effectively it wasn't being used as a good form of ventilation. And you'll notice around the bathroom there's lots of dampness on the walls and mould. The kitchen, apparently the kitchen wasn't used very well, but it wasn't properly ducted out either. So not effective ventilation from the kitchen, worth looking at that. So have a listen to the data loggers. Section on the data loggers. So you can easily load them. Just take your files and drop them into this section here. This then loads 3 files. What we're going to do is we're going to compare the damp wall to the closest source of vapour. In your case, the bathroom's actually some distance away. So but that is the source of vapour. The property was vacant at the time, so it doesn't really give us complete information. So here's the graph. And there are 3 things that we're looking for in normal circumstances. By the way, it's at damp.ai/detect. So surface relative humidity, and at the time of the survey, but it was in September, it doesn't go above about 75% relative humidity on the surface. So it's not indicative of condensation during that period. But then I think this happened some time ago, and a damp wall takes 6 to 9 months to dry out. So the other 2 other things to look for are the dew point. So the dew point is a measure of the amount of vapor in air, and you'll see it's pretty constant, and that is, well, primarily because there's no ventilation, and the internal temperature is very constant and the relative humidity is constant. All these 3 things work together. And you want to make sure that the internal dew point is above the outside temperature. There are a few periods when there's quite a big difference, and that is because the cold wall, so near to the subfloor void, is going to be cold, even though it's central. It's an internal party wall, should I say. So this is a period when you've got a risk of condensation on the wall. And then the other thing is the relative dew point, so the dew point differential. And when it's above 0, it means that there's more vapor coming from the living room in this case, or the damp wall. And when it's below, there's more coming from the bathroom, which is strange because it was vacant at this time. So there could be good reason for that. And sometimes it's because there is ventilation in the living room, but not in the bathroom. I'm not really sure. You'll know better than I will do why during these periods. So if we zoom in on the 19th, let's see, why was it around this time that there's much more vapor? There's much less vapor in the bathroom. The living room seems very constant. I wonder whether there is some natural ventilation in the bathroom. That's probably it. Is probably just to do with natural. So this is when we're getting higher. Well, if there's natural ventilation in the bathroom and it's raining outside, you'll have the effect of water. That's why I tell people whenever leaving a property vacant, you should run a dehumidifier, 20-litre dehumidifier. And in this case, I would increase the speed of drying out by putting a fan up close to the wall if you can. Just a normal heated fan without necessarily the heat on works fine. So in conclusion, the issue is condensation. It's made worse by the bookshelves because they're slowing down the flow of temperature from the radiator to the wall. obviously lack of ventilation is the critical issue, bathroom, kitchen ventilation. I think it's exacerbated by probably the neighbour going away, but it's up to them if they want to turn the heat off. And obviously low temperature in the subfloor void, but that's normal, so nothing unusual about that. And I understand that a lot of clothes were being dried inside. Now, best thing to do is use a dehumidifier. 20 litre dehumidifier is really the sweet spot. It's probably better to get one like a Miko that rather than hiring one. And a fan will speed up the process because it's just speeding up the drying, essentially. But no major problems. It can take 6 to 9 months to dry out. That's the only thing. But you can probably start repainting it fairly soon.